Hello there, grade 12s. Welcome to the second lesson on vertical projectile motion. Right, so today we'll be looking more into what we call the equations of motion. Right, so now these are the formulas that we're gonna be using now to calculate now the components in vertical projectile motion. Right, so we are gonna be dealing with the equations of motion, because here we are trying to deal with motion. Now, even before we go further with this here, you should be aware that when we are dealing with vertical projectile motion or dealing with motion here, we are dealing with a vector quantity. So in other words, in whatever that we do, always take cognizance of magnitude and direction. So these are very important components that you need to be aware of when dealing with vertical projectile motion. Right. In fact, in mechanics, as far as I'm concerned, please always make sure that you make use of these two. Right. Okay. So now let us get into the equations of motion that we have. Right. And why and what do we use them for? Right. So the first equation of motion that we have is the one that says the final velocity will be equals to the initial velocity plus the acceleration multiplied by time. Now, what is this formula used for? So if you are looking for initial, you are looking for final velocity here. Right. So I've seen that people most times struggle with now finding what is an initial velocity, what is the final velocity. Now always analyze the scenario and see now where did this thing start and where did it end. Now that will give you the idea in terms of what happened first and what happened last. For example, if we can have an object being thrown up, right, at a velocity of 2 meters per second, right, then when it falls down, it touches the ground with a velocity of 5 meters per second, right, per second. So now you be aware that the first situation that happened here was the object being thrown up. So that would be the initial velocity. Now the object now coming down now would be after the ball was thrown up. So that will have to be the final velocity. So I'm trying to say here, always try and analyze the situation in terms of what happened first and what happened last. That will lead you now in terms of what will be my final velocity, what will be my initial velocity, right? So this formula here, we use it when either you want to calculate the final velocity, the initial velocity, or the time. Now always remember that when we're dealing with vertical projectile motion, we're gonna have our acceleration at 9 meters per second downwards, right? So that is very important to also mention now in which direction. They like this question. So always remember that the gravitational acceleration will always be 9.8 meters per second downwards. Unless now there is a change in velocity, which is sometimes rare, but you should know that your acceleration will always be at your 9.8 meters per second downwards, right? Okay, so now, how will you know when to use this formula? When you analyze a question, always, now when information is given to you, now analyze, have a data at your side that, okay, this object was thrown upwards. Therefore, I'm going to have my initial velocity, right, at a certain magnitude in terms of the velocity going up, or that is going to be my initial velocity, right? I'm still going to do examples of questions, and we're going to look at how to work around those logistics, right? So what is the second equation of motion? The second equation of motion now says the change in displacement vertically. Remember, we are dealing with the vertical direction here. So the change in direction vertically will be equals to the initial velocity multiplied by the change in time plus 1/2 or half of acceleration multiplied by time, or the change in time squared. Now always make use of these things here. So remember, change simply means now the final displacement minus initial displacement. So you can always opt to use this here. This is allowed. It doesn't mean that this should be a specific number that you just take here. So if you're trying to understand the situation, just see that, okay, now this was my final velocity minus my initial, right? So you can always go back to this. The same applies to time. So that is still allowed, right? So, but always remember that you must always now consider your direction. So it's either you take your up as positive, or you take your down as negative, right? It's up to you which direction you use, but please be careful. Whatever direction you choose going up in a question, stick to that in the rest of the question. So, right, please. Going on to the third equation of motion. Now, that is the one that says the final velocity squared will be equals to the initial velocity squared plus 2a change in y, right? So you can see that we are still dealing with vertical direction here, which is change in y. Please don't use change in x, because now you'd be referring to horizontal displacement, right? So please be physicist and please try to be accurate as possible. Now your answer might be correct, but please make sure you use your change in y, right? That is very important, right? Okay, now, okay, coming back to the last one. Now that would be the one that says the change in y would be equals to the initial velocity plus the final velocity, all divided by 2. Now, so in terms of when and how to use this equation of motion, now that would be on the scenario in terms of what information were you given and what are you asked to calculate, right? So obviously, if they would tell you that they want the time, now you need to look at what time do they want in the situation. Do they want the time that it took for the ball from up to the highest point, all those things, right? So that is why it's important that when you do physics, you write down your data, so as to understand, what do I have, what do they want, now how am I going to substitute and what formula am I going to use, right? So that's a very important procedure. Now let us look at triggers now that are important when it comes to vertical projectile motion, right? The first trigger that you should also always know is that of contact time. So when you are talking about bouncing object, right? So let me try and remove that, right? So when we are talking about bouncing objects, we are always gonna expect contact time. So let me remove that so that I'm able to illustrate this in a way that is very effective and efficient. Right, okay. So now let us check here. If we are talking about bouncing object, so when we are told that an object was bouncing, so an object went down and it bounced, or there was contact time. Now maybe it stayed here for 2 seconds, now it went up again, right? So always take cognizance of contact time. And in such situations, your final velocity and your initial velocity will now change. So if you'd find that if this was the initial velocity and this was the final velocity, now when you want to calculate the contact time, now this will be your initial velocity here, and now this would be your final velocity here. Because now you want to look at the distance or the time between which the ball bounced in the ground and it was in contact, then it now went up, right? So I'm just showing you in terms of how you should think of vertical projectile motion. Now that's the first thing you should look at. Now the second thing would be maximum points, right? Or time symmetry. Let me look at time symmetry. Now what does time symmetry speak to? Now that means that if we were at a building here, then there's a person here now throwing a ball upwards. So if this person throws a ball upwards, now it will move upwards and it will come to a certain point, which is the maximum height. Then at a point again, it will come down here. So the issue of time symmetry speaks to that the time it took for the ball from the same height here to go up to a maximum height, it is going to be equals to the same time it took from the maximum point to the same level here. So the time here would be equal. Right. And what do we know about the velocity at the maximum point? You should know that the velocity at the maximum height will always be equals to 0 meters per second. Because at some point when the ball is projected upwards, it goes with a reducing velocity, then it comes to be 0 here. Then it starts again now dropping down here, right? So what you should know here first is the issue of time symmetry and the magnitude of velocity. That the velocity from here to here will be equal, and from here to here will also be equals to this one, but now in the opposite direction. So you must always take cognizance of the direction in this regard, right? So now those are some of the things that you need to be looking at, right? So when they tell you in a scenario now, an object was projected upwards, an object was thrown. So when they tell you that an object was projected, when they tell you that an object was projected or thrown, always think of the object having an initial velocity. What is the initial velocity? Right. But when they told you that an object was dropped, immediately you know that now this initial velocity here is supposed to be 0 meters per second, because it means that this object was just held here, then now it was left to fall, right? That will mean that at some point initially it was at 0 meters per second, right? Please be aware of such triggers when it comes to exam questions. So I'm still gonna be dealing with that when I do pass exam question papers, right? So I'm just gonna be doing that, almost approaching to your guys test times, and I know we are approaching to that very fast, so you should be expecting that later on this week, right? So please guys, vertical projectile motion or physics as a whole is not a hard thing, so just relax and try to understand the concept. Then from there everything else will be much easier, and please do justice by also doing your question papers, right? Other than that, this guys was the end of the second session of vertical projectile motion. Now join me next time when we will be looking at the graphs of motion, looking at displacement, velocity and acceleration, right? I hope that this guys was very useful to you and that you understood very well, and that it will help you towards your achieving your academic excellence, right? So please make sure that you also share this information, guys, with people who are in need. Make sure that if they can't access this, you download it for them and you send it to them, because it's very, very important and very crucial, right? So I hope that this guys was useful to you, and have the rest of your day good. Bye.